Welcome. Have you ever installed a solution, walked away, and then was later surprised when it developed issues? Well, today we'll walk you through General Mills' journey with Tableau Server, all the way from setup, stabilization, and walking away to developing some of those issues and how we overcame them. Today, my goal is to show you just a few of the tips and tricks that we used to tune our Tableau server. I'll be talking briefly about me and my company, and then taking you through our journey from startup all the way to today. I mean, after all, my manager asks me, is the environment running efficiently? When do we need to increase capacity? So those were my goals. My name, Patrick Phillip. I've spent almost 20 years as an IT professional, at least 12 years fooling around code before that. My previous roles include IT analyst, developer, system administrator, project manager, and currently, my role is Tableau system administrator. What is General Mills? Well, these are a few of our brands, but just a few. We have over 40,000 employees worldwide. We're headquartered in Minneapolis, Minnesota. We make food people love. According to the Vice President of Information Technology, all companies are technology companies, whether they admit it or not. And what he really means by that is that technology is foundational, even if you're just making food. Of course, the most important thing to know about General Mills, we use Tableau. One big warning, this presentation is our journey. Your mileage may vary. Our journey spans from June 2016 through today. We'll begin right at the beginning. Well, in the beginning, we officially launched Tableau Server as an enterprise IT-supported system. We made Tableau Desktop available to all of our end users. Prior to this, there were only a few small pockets of users throughout the business using Tableau Reader and Tableau Desktop. We spent a lot of time in our pilot phase prior to this, working through our security, through our project setup, best practices for using Tableau. We took advantage of the jump start, but one thing to note is that the jump start happened before we had any traffic on our Tableau server. We had decided on Tableau because it really is a market leader of self-serve visualization. And we are licensed for 8 cores, so basically 1 server license. In the beginning, we had 7 consumers authenticated on our server, and 63 workbooks had been published at that point in June 2016. But it's important to note that the vast majority of those 63 are really tests that we were doing during the pilot phase, and we just never got rid of them. So we move into the early adoption period, summer 2016. During this period, another 50 people received desktop licenses. People were really getting used to using Tableau and building workbooks at this point in time, and self-service was our primary goal. We wanted to reduce the reliance on IT for every step. One team at this point had requested their people to be set up and authenticated on the server, but most of the publishing was test publishing. Server usage at this point was extremely minimal. So what does that look like? We went up to about 540 people who were authenticated on the server during this period, and the number of workbooks went up to 99. So now we get in towards the end of 2016. and I like to call this period quiet growth. We purchased another 100 Tableau desktop licenses. People are really diving into using Tableau Desktop. They aren't publishing for usage quite as much as we might have expected yet. They're primarily exploring their data and exploring what Tableau and Server can do more than publishing for the masses. Knowledge about Tableau is spreading by word of mouth, communicated via social media, in our case, Yammer. We have consults with architects. We have architect presentations to solution managers. We have director presentations to senior leadership. I would call this the calm before the storm. Everything will just work, right? We are not paying a lot of attention to our server. All right, we've authenticated a few more people at this point for using the server, and a few more workbooks are getting published. People are beginning to use the server, but nothing that's calling our attention to it at all. And we turn to 2017. 10,000 users? Where did that come from? That's 25% of the entire company. It wasn't like that just a few months ago. Is it real? Turns out this was just one user group. We started receiving multiple reports, reliable reports, mind you, of slowness. The same report would be fast one day and slow another. People would start sending us screenshots of error messages that they were receiving, but we can't track down the root cause. We suddenly realize the dark side of our self-service goal. We have the wild, wild west. Anything goes as people design workbooks. What can our servers realistically handle? What do we do about this? It's at this point that I'm brought in to debug our server setup. Early spring 2017, I learn and apply. So as part of learning, we hired a week-long professional services engagement with Tableau. I also took a Tableau Server administration class. My goal was to apply everything that I was learning and attempt to improve the system. Make a change, see how much the server improved, wash, rinse, repeat until we get acceptable performance out of our servers. So what did I really want to learn? I really wanted to know how Tableau worked underneath the hood. I wanted to be able to identify our bottlenecks, find root causes, and not just randomly change server configuration settings. I actually wanted to understand what's going on. But that's not all. I mentioned earlier that we had been looking at best practices, but those best practices that we'd been getting were for Tableau workbooks and authors. We realized that we didn't have best practices for running our server. Well, okay, great, but also how do we monitor what's going on the server? If our server has a problem, I'd like to know about it before 10,000 people call me. So what were some of the things that I had learned? We'd never tuned our server. So the jump start gave us default starting recommendations. These recommendations were never meant to last the test of time. They were just getting us started. So that leads us to, we needed to be tuning our server for actual traffic. we didn't realize that we're supposed to be changing those dials and knobs depending on what kind of traffic we were actually seeing on our server. So what was some of those big levers? Well, one of the biggest levers is changing your process counts. And the two biggest processes that you might want to change are the backgrounder process and the VizQL process. So the backgrounder process is really going to handle running your extracts, running your subscriptions, and some of those other things, whereas the VizQL processes handle rendering your workbooks as people request them live. So what does your traffic look like? Is it primarily people running extracts with very few people actually querying workbooks, or is it the reverse, or is it some mix? What your traffic was mattered a lot for how you tune these process counts. And when is it happening? Is it all people viewing workbooks during the day and extracting during the night? This all mattered. All right. Oh, one other big point is that we only have one server that we were licensed for. VizQL is limited to, you need 2 cores to support each VizQL process. So with an 8-core system, we knew that the maximum that you could enable was 4 VizQL processes, and the recommended that it starts with is just 2. Well, how can you guess how many processes you need? We needed to know what was going on underneath the hood. We needed to know what was happening underneath that quiet exterior. So, which processes were used for different types of service requests? We also knew that there were different process limits. So, as an example, VizQL process is limited to a certain amount of gigabytes of RAM, and that's configurable. It's specified in the config. Whereas knowing that your backgrounder process, it'll take your entire server if it can, or if it thinks it needs it. So it's really important to understand how each of these was working. Finally, it really became important to understand how various levels of caching worked, because that's where you're going to get some of the performance speed-ups. So we'll talk about more in depth the tile, model, and query cache as we dig in. This right here is a high-level overview of the components in a Tableau server. Requests are going to take different routes through all of these components depending on the attributes of the request. So as an example, a background process to run an extract is going to have a different route through all of these than a request for a workbook view that uses live data, and that would be different than a workbook view that uses extract data. All of these have different paths throughout. So let's take one specific example. Let's say that you have a published workbook using a live data source that does not happen to be cached at the moment, and a published data source at that. So where's it going to go? It's going to start with the gateway, and from there it's going to go to the app server. From there it'll go to the VizQL server. From there it goes to the repository, back to the VizQL server, to the cache for a cache miss, because I mentioned that the data hadn't been cached, then out to the data server, out to your database, and it'll wind back through the VizQL server and back to the end client. And that's just one type of request. So let's dig a little bit more into each of these components to understand why this particular path happened the way it did. The gateway process is a broker. It decides where to put incoming requests. Now, this is a little less important with our particular setup because, as I mentioned, we really only had one worker server. But if you have a multi-server setup, that gateway process does become important, because that's going to decide which of your worker nodes it's going to send requests to. Well, the next thing we hit was the application server. This is what handles your login authentication. How does it know that it's allowed to even give me that data, that workbook view? So this is the very next stop along the pathway. The VizQL server is responsible for everything related to rendering a view. And it also handles all coordination with all of the sub-processes that are needed to render that view. So this is the big daddy of it all that handles everything that goes on from here on out. Well, the repository is where your workbook goes when it gets published. So the VizQL process needed to go there and go look up the definition of your workbook. Otherwise, it wouldn't have known what it was supposed to work on. The TWIBs are stored actually as XML in a blob field. The data server is what handles all published live connections. This coordinates getting data from your database. One note on that is that it does not handle data if the connections are embedded in your workbooks. It's only for published data sources. Now, we didn't talk about this on the previous path, but for a little bit more completeness, the data engine takes the place of the data server if you're using an extract data source. And of course, the file store is where those extracts get pulled from. I mentioned the backgrounder process. These are the ones that actually handle everything related to getting the data in from a database and stored into that file store. And as you'll see later, they can be very, very expensive. Finally, the cache server. This is the shared query cache. It's usually kept one-to-one with the VizQL processes, and this is what stores what comes back from your database.
The background is also for email subscriptions, right?
It's also for subscriptions. Correct. So yes, the backgrounder also handles subscriptions. So let's talk about the caches that I referred to on the previous page. All right, we have water malfunction. So the backgrounder process. Okay, slide went when I spilled the water, everything just zoomed ahead. Sorry about that. So the tile cache. The tile cache is specific to the gateway process, which is where it is located. The tile cache is what saves off rendered pictures of different workbook views. So if you were to give one specific example, this workbook, these parameters generates this image, that image will be stored in the tile cache. It's really important to note that this is resolution specific. So if a person with an 800 by 600 resolution monitor is requesting that view, that's going to be a different rendering than somebody who has a 1600 by 1200 resolution monitor. So then that will then generate a cache miss. The model cache is located inside your VizQL process. This is the next layer down cache. So again, with that example, you have one workbook view that has the same parameters calling into it. Well, now somebody's asking for it at a different resolution. The model cache stores everything, all of the work that it needed to render that image so that it can quickly render the same image at a different resolution and store that in your tile cache. And so that's where what the model cache is used for. This is typically only used when there are no user filters in play, however. The query cache is stored in the cache server, as I alluded to before. It's what's going to store your database results. So all of this data that comes back from your query to the database, that's right there in the cache server. So what decides when things are pruned from the cache? Because that will directly affect your performance. Well, each cache has a specific limit in terms of number of items or a megabyte limit. And it's typically unheard of for users to, well, server administrators to tweak these settings. They're normally left in place as Tableau set them. So then, what happens when the cache is full? Well, it's first in, first out. The first thing loaded will be the first thing dropped from your cache. So if your most popular report that is used all day long is the first thing loaded in the morning, if enough other requests come in during the day, it will also be the first thing dropped. There was a question?
If you're using extracts, are the results of those queries stored in cache server at all or not?
No, the cache, so the question is, if you're using an extract, is that data stored in the cache server? And no. I'm not 100% certain, but I would imagine that the data engine would take care of any kind of extract caching. But don't quote me on that one. I didn't spend as much time in that process. All right, so what else did we learn? Well, I read up on the Tableau scalability white papers. I learned that Tableau scales linearly with your worker nodes. So if you have 2 worker nodes, you can handle about twice as much traffic as you could with just 1. Also learned that everything is topology based. So what is your traffic? When are your peaks? How is it used? How often is your data refreshed? How often are those workbooks called upon? They had this particular 9-section grid just identifying 9 major types of traffic that you might have. In our case, we tended to stay between cases 1 and 4. Typically, our data was only updated once a day, and depending on the specific report, those workbooks might be called once a day or maybe a few times a day. But your traffic may vary, and they give some pretty good examples of what the different types of topologies might be that you'd want to configure for. I also learned about the Tableau Workgroup database. This is the PostgreSQL database that holds everything that runs Tableau Server. So there is a wealth of information stored in here that you can get at and use to help you monitor what's going on with your server if only you can find it. And so this data dictionary is a lifesaver in order to enable you to be able to navigate your way and find important information inside that database. We'll talk more on that later. All right, so I learned all sorts of things in those 2 weeks. It's time to start applying what I learned. Our user traffic has stayed pretty consistently distributed per this graph. So our traffic tended to take off at about 7 in the morning. We tended to have a dip during lunchtime. And then traffic really settled out at the end of the day when people left around 5 p.m. Now, originally, we only had one schedule for our extracts. So we had a ginormous spike at 6 a.m. Now, this picture is artist interpretation. We never actually saved any of the metrics during this period, so I remember looking at it, but we didn't save it off. So this is just my own personal interpretation of what we were looking at. But yes, we had one giant spike around 6 a.m., and we had jobs that would be starved because they would be busy waiting for one of the backgrounder processes to get to them, and they would time out waiting because the backgrounders were just way too busy. So how did we start applying all of this information? First and foremost, we changed our process counts. Originally, we had 4 backgrounder processes. We went down to 3. Why? Our intention was to solve this problem through spreading the load out over a much, much wider schedule rather than having more processes handle all of that traffic. We'll get deeper on that in a moment. We went from 2 VizQL processes up to 4, the maximum that our box would support. Why did we do that? Well, our goal was to have high throughput. By having 4 processes, we knew that we would be able to service 4 workbook views simultaneously. And there wouldn't be any queuing as long as it was kept under 4. By setting this to 4, we knew that we were making a trade-off. We were going to have half as many resources available to each of those processes as we did when we only had 2 VizQL processes. 4 processes running on the box instead of 2, they'd get only half as much resources available to them. But we wanted to make that trade-off. We wanted to be able to support more people coming in simultaneously with smaller workbooks rather than just few people coming in with really large workbooks. And here was another really large, very helpful thing. We increased the RAM on our server. We had 32 gigs of RAM originally. We went up to 72. A lot of what Tableau Server needs to do is extremely RAM intensive. And I'm currently debating about just how much further I want to push this. I'm currently in negotiations with our hardware teams about increasing this even further. Just because we increased the amount of RAM in our box didn't mean it was going to get used. We needed to set the configuration on our various processes to say you're now allowed to take advantage of more RAM. So that was an important configuration change. We also decided to decrease server load. We had been synchronizing our security with Active Directory 96 times a day, every 15 minutes. And it took about 50% of the CPU for about a minute or 2. Well, we decreased this down to just twice a day and decreased the load on our hardware tremendously. All right, how else did we apply? Many teams in our organization have jobs that update the data in their databases overnight. Very few people are updating their data in the evening, say 6 p.m. to midnight. Mostly it happens during our dead of night. So we created all of these schedules to try and spread out the load from midnight until maybe 9 a.m. in the morning. So we set up a schedule every half hour, and we worked with these teams. When do your ETL jobs complete? We wanted to make sure that when we set their schedule up for their extract refreshes, we wanted to make sure that we would run it after their ETL jobs are done, but we didn't want to have all of those jobs running on the same schedule. And we took time to make sure that if we put a lot of jobs into one particular schedule, would they all complete before the next load came in, or would they keep timing out? It varies. I didn't actually, so the question was, how many teams are we talking about with 10,000 users? I don't exactly know. We had, because I don't know how many teams are doing extracts, I would say that at this point in time, we had perhaps 40 or 50 extracts running. The number of teams that represented was perhaps a dozen at most. Well, one last thing that we're working on and actually finishing up right now is that we have an enterprise scheduling system that runs in our company. And we know that ETL jobs sometimes run a little long. Maybe the data isn't ready when we thought it would be ready. Tableau has the ability for you to call through a command line for an extract to happen ad hoc. Well, we're writing our own component to tie our scheduling system to the refresh extract kickoff. And so we can use our enterprise scheduler to say, this ETL job is done, now kick off that extract. And we know that'll help a lot in terms of making sure that these schedules work better for our end users because they won't run before their data's updated. Well, that was a lot of learning and applying. What else did we learn? We learned that it's not enough just to change your server. The best tuned server in the world can get buried by a poorly written workbook. It's entirely possible for somebody to create 2 different workbooks that solve the exact same business question. One will run quickly, and one will bring your server down if there's just 3 or 4 people running it at the same time. So it is extremely important that we work with our authors to tune those workbooks. All right, well, what are some of the things that we learned about tuning those workbooks? Fixed sizes on those dashboards will help you use the tile cache. Instead of letting the default setting on the dashboards continue where it'll just automatically resize the dashboard based on whatever resolution your end user happens to have on their computer, if you were to fix your dashboard size, it will only ever render at that size. Depending on their resolution, they might get scroll bars, but now you can start using that tile cache far more effectively and reduce the load on your server because the request never gets deeper than that gateway process. Another recommendation that we learned was avoid high mark counts. More marks equals a longer rendering time inside the VizQL process. We learned that people should really work with just extracts, subsets of their data. Sorry, extracts is an overloaded term, just subsets of their data. Only use what you need to render your particular view. The more data you're bringing back, the more load you're going to put onto the server. And consider those number of filters with quick filters. Quick filters will also add a lot of load to the server. Instead, use dashboard filter actions. Those have a lot less impact to your server performance. At the end of the presentation, I have URLs that link to much larger lists of different workbook recommendations, tuning structures. What else did I learn? I learned about the performance recorder. The performance recorder helps us identify just what your workbooks are doing and where they're spending their time. On desktop, you can see over on the left-hand side there, this is how you start the performance recorder and figure out just where your workbook is, what it's doing, where it's spending its time. On the server, you would need to add this query string to the end of the URL where it says record performance equals yes, and then it'll give you a little performance recording button that you can click. Pro tip, don't tell your end users about that. Use it just for yourself. It's expensive to run performance recording on your server, and if you were to tell hundreds of authors just about, hey, look, you can see how much resources you're taking up on my server, they'll bury your server finding out. So just use it for yourself and ask them to go ahead and use the one embedded within Tableau Desktop. All right, so I mentioned the performance recorder. What does that look like? I ran it on one sample report here. What did I learn about that report? I learned that it spends a lot of time querying the data relative to everything else that it's doing to render that workbook. And the next most expensive operations were computing the views. So the number one question I might ask is, can we tune the database or those queries? Can we make less expensive views? Now, I'm not showing you this particular workbook, but the workbook is a crosstab report. Every cell in a crosstab report is a separate mark. So this means this is a very high mark count report. So yes, they probably could tune their workbook views quite a bit in order to reduce the compute time, but we'd have to look in more in order to see if there's anything we can do about that database time spent. Great, so I learned that tuning your workbooks is very important. That's not going to do me a whole lot of good because I'm not actually responsible for authoring them. I needed to tell our authors about this. So we have all kinds of training in that we've published best practices out on a website dedicated to Tableau authors to be able to collaborate and share information. We've also been using this through Community of Practice monthly meetings, advertising that there are best practices that people can use and that there are ways to tune your workbook for better performance. My next step of applying things includes monitoring. Tabmon and LogShark are two tools that Tableau Professional Services created and then released to the world on GitHub as open source. Tabmon allows you to monitor the performance counters on your server, and it also is able to read the JMX counters that Tableau Server publishes. It'll store this information into its very own PostgreSQL database, which you can then query for your own reporting. And they come with built-in reports. LogShark will summarize all of your Tableau Server logs and output the information as a Tableau workbook visual. And this makes it a really wonderful tool for first pass on finding out what's in your log files. Because I don't know about you, but I don't find those logs particularly easy to read. Finally, I found out that you can customize those delivered reports that come built in to Tableau Server. And I will have links at the end that show you where you can go in order to find the workbook on your server so that you can download it, learn from it. You can learn how it queries the workgroup database that I mentioned earlier in order to better find the information that you might need. And you can just perhaps customize those reports to make them a little bit more useful for yourself. All right, so we had 10,000 users. We found out that that was a lot of eager allocation in terms of adding people to the security groups. Over 9,000 people really were never going to be using those Tableau workbooks. Oh, that was a relief. We were not ready for 10,000 people coming in all at the same time. But that doesn't get them out of Tableau Server. Just because we asked people to clean up their Active Directory groups didn't remove them from Tableau Server. And so it wasn't going to be easy to see just from a Tableau Server admin point of view, how many users do you really have? You had to actually physically remove them from the Tableau Server itself. And so we found that there was a tab command that you could use, feed it a CSV file, basically one user ID per line, and it would go through and delete all of those users out of the system. You really couldn't see how many real users you might have without being able to do this type of a cleanup. So that scary 10,000 number went away. We're still over 1,100 users authenticated to use our server at this point, but that's doable. We could handle that. We didn't suddenly need to add another 20 servers to our, to our environment just to be able to handle the traffic that that would have represented. And of course, workbooks continue to get published. We're now at 245 workbooks available on the server. That brings us into late spring, early summer, when we started putting in the basic monitoring around our server. So let's start with one of the graphs that we got from Tabmon. What is this? Here we have disk queue. So it's going to tell us if our hard drive is a bottleneck on our server. You know, each read and write that needs to be done to disk, are they queuing up? Is our server able to keep up with the demand of people making requests that cause reads and writes on our hard drive? If we saw spikes in here that started correlating to spikes on other graphs of high traffic, we'd have an idea that maybe our hard drive was our bottleneck. Here we see overall CPU utilization. So, as I mentioned before, we had an 8-core license, and so we fit it with an 8-core server. That means that in this particular case, the graph should go to 800%. In this case, I didn't see CPU as a sustained worry for us because we had a lot of CPU capacity left remaining. Yes?
How much history is kept?
The Postgres workbook database, by default, would keep 7 days. Tabmon keeps, I think it keeps it until you remove it, but don't quote me on that. I haven't been too worried with how much data Tabmon was keeping in these. I have worried about how much the workgroup database was keeping, and I will show more about that a few slides from now. So I'm not so worried at this point about our CPU load. We're never pegging all of our CPUs. So great, we know that we don't have to worry too much about overall CPU load, but where is that CPU getting used? Well, when we broke it out by process, we saw that the backgrounder was pretty much the largest single use of CPU in our entire server. So when we had a lot of extracts or subscriptions running, we knew that our CPU load might get extremely high just because of the backgrounder. As much as possible, that tells us we want to keep the backgrounder running when people are not using the server for actual workbook views. All right, this graph is processor queue length. So how many threads are waiting in line hoping that the CPU will get to them? This gives us some kind of indication of how much traffic do we have coming in all at the same time. You can see that at one point here we had spiked to 12 people waiting in line hoping that a VizQL process would get to them. This is why we wanted that higher throughput with 4 processes rather than the lower throughput that we would get with only 2 processes serving at the same time. For us, sometimes our traffic comes all at once. Yes, sir?
What is your personal experience with VizQL being multi-threaded? Because we were told by some Tableau people, like you can't do multiple people, you will single process, but you say you can do like 3 processes for VizQL. Doesn't like multi-threading help achieve the simultaneous performance?
The question is, does multi-threading help the simultaneous performance with the VizQL server? Well, we learned that VizQL will only handle 1 request at a time. So even if the VizQL process is multi-threaded, it just means that it can work on that 1 request through multiple threads, but it's not going to take the next person in line who requested a workbook. Not until it's done with the current one. All right, this graph on memory is probably inverse. It's memory remaining or available. So lower is bad. We have 72 gigabytes of RAM, as I mentioned earlier, and we're using all of it. So, yes, we have very, very memory-intensive processes happening on our Tableau server, and this is part of the justification for why I'm going to be going back to our hardware people and asking for more. One of the reasons why you might want to look at this is, how do you build your hardware? Do you build it for your peaks, or do you build it for your average case? It depends entirely on your service level agreement with your customers, but for us, we try to build for the peaks. Now, this one does not come from Tabmon. This one comes from the workgroup database. This is concurrent sessions. How many people are hitting our Tableau server at the same time? Well, why did I get this? I really wanted our usage trends. I really wanted to get an idea of how many people are simultaneously running sessions on our server, and is that trend growing over time, staying the same, decreasing? Because that was going to let us know if we were going to have any type of capacity issues where we might need to add another server into our environment in order to be able to handle the incoming traffic. Now, as I mentioned before, the workgroups database only stores 7 days of data by default, and that wasn't enough for us. We wanted to see trends over a much longer period of time. So we ended up having to build our own extract from the database and putting it into Oracle because the default Tableau extract wouldn't let me set the primary key the way it needed to be. So we extracted to Oracle, and we're keeping a much longer time frame of this data so that we can see that, yes, we're slowly increasing our concurrent trends. Another thing to note about this report is that it only shows positive data. It's not showing the holes in the data. So when it says that we have an average of 3 users on the system at all time, well, that means an average of 3 when there are users on the system. When there are no users on the system, there's no data getting logged in the database. The question is this report available out of the box, or is it custom code? This report is one that I built. So the data is data that I got out of the database, the workgroup database. I figured out how to pull it out of the table using the data dictionary that they provided. And then I simply wrote this report to show session start times and end times and doing a running total in order to be able to see how many people that I have or leaving would start dropping this information. Yes, sir? The question is, am I pulling all of the tables out of the PostgreSQL database, or just which ones in particular? In this case, we didn't want to duplicate what already existed. We're pulling only the query I needed in order to render this report. And that's what we're extracting and saving in a separate database. As we identify additional needs, I'm open to expanding that, but I figured start with the first use case instead of trying to gold plate and future-proof too early. All right, now, despite the fact that I kind of dissed crosstabs earlier, yes, I made a few crosstab reports. I just couldn't figure out how to make a useful solution for myself without having it be delivered in an Excel-like format. Extract owners. You kind of get that wonderful little thing that says an extract failed in that upper right-hand corner of your server, but if you want to actually work with who owns that extract, it's not the easiest thing to find. So I created a report that matched up all users and the extracts that they owned so I could know who to call if ever I wanted to complain to somebody about an extract that's causing a problem on my server. The intention is never that I would dump all of this out to a separate file, but I could just pull up this report, filter to the extract name, and find out who owned it. Data source and workbook mapping. When I want to clean up content on my server, which data sources are used? Which ones are unused? How many other people and workbooks are sharing that same data source that I'm about to significantly modify? This type of a report is going to let us know across projects and across sites just what that kind of usage looks like and help me find downstream impacts. Remember when I wanted to remove users from the system in order to be able to see just how many people were really using Tableau Server? I made a report to actually map users and groups. By mapping users and groups, I could see who only belongs in the all users group. Because if they're in the default all users group, then they don't have access to any one of the Tableau projects on the server, which means it's safe to delete them from the server. This report, Last User Login, helps us with end user adoption. Who's using the system? How recently were they using it? Do we have people getting secured to use Tableau Server and then never logging in? Yes. Do we have people coming in maybe just once and never coming back? Yes. Workbook owners. I wanted an easy way to associate a particular person's ID with all of the workbooks they own. It's easy to see this in Tableau Server if you're only looking within one project, but this report will look across all projects and all sites. So now, if people are secured to use more than one project on the server, I can see everything that they own. That helps a lot because you cannot delete users out of the server if they own something. So just because they might have been removed from Active Directory security and no longer belong to any of the groups on the server, you can't delete them if they're owners of various workbooks. All right, I need to reassign ownership of all of those workbooks because maybe that person left the company. This report helps me figure that kind of information out. Now, our end users really like this one because they want to know who's using my dashboard. How often have they been using it? When was the last time people are logging in? Well, I just made a quick and dirty report that gives us that information. And a while back, I mentioned that you could customize the built-in reports delivered with Tableau Server. The biggest change we really wanted to make was to take it from just people's user ID to add in the friendly name. And of course, I've blanked that out to protect the innocent today. But that was the biggest change that we made to our delivered Tableau Server workbook. All right, well, end of summer, early fall. We started working on some more advanced monitoring. Our big step here was to implement Interworks Power Tools. Why? This was the first tool that gave us the best alignment of CPU and memory consumption to what processes are physically running on the box at that point in time. And then it let us drill down into those processes. They also have a desktop tool which goes a few steps further than the performance recorder to help authors tune their workbooks. So let's dig in and give you one case example. Right over here, I found that we had a workbook that took 1,800 seconds to render. Now, it might be hard on this screen, but when I highlighted this particular spike in my graph, there's little gray bars that show me when it lines to concurrent users, where it lines up on our CPU chart, which processes are running at that time, what background tasks are running at that time. And it lets me see at a glance how everything lines up. Trying to do this on my own, I figured would have taken me a really long time, and I hadn't figured out where to get all of that data. So they'd already solved that problem, and we brought them in. But they're going to let me dig down deeper into this particular request, this particular view load. So when I go into it, I can dig into the VizQL session, and I can see that it ran 11,000 seconds worth of queries in parallel, so it was multi-threaded, but that still took 1,800 seconds on the critical path. During this period, we can see up above, the average CPU was 87.9%. All right, that's a little busy. I think we have a workbook that needs to be tuned. Furthermore, it's going to let me dig into every query that was run as part of that session. So we can tear this thing apart down to particular queries and work with our authors in order to see just how this workbook is put together and how can we tune it to improve its performance so that we don't start seeing spikes like this on our server. I expect this type of monitoring to be able to help me be particularly proactive in just monitoring the server and keeping ahead of any kind of heavy resource consumption and allow me to work with our authors in order to head problems off before people bury our server with them. This will help us bring some measure of order to the wild, wild west of self-service. At the end of this period, the server's running pretty well, even though you can see that our authentication count has gone up to over 3,300 users authenticated, and workbooks continue to get published, 621 here. So that brings us to today. Where do we go from here? We're not walking away. We have to keep monitoring the system. I'm going to want to find and fix errors as they occur and before too many people notice them. I have to keep an eye on that traffic pattern. As the traffic changes, I'm going to have to reconfigure the server. And then I need to keep identifying poorly performed workbook, poorly tuned and performing workbooks because people are still going to publish them. We wanted self-service. There's no control preventing people from publishing. So I'm going to need to be able to keep my eye out for people running workbooks that take up a lot of server resources and work with them to tune. All right, that was a lot of information, and I promised you source material. So here are links on creating those custom administration views. More information on the workgroups database. Different examples for doing server performance tuning. I'm fairly certain that they're going to provide this deck after the conference as well. Oop, I clicked on the actual link. There we go. I have more links. Workbook tuning. How to use Tabmon. How to use LogShark. And where you can go if you're interested in Power Tools. Finally, please fill out your surveys. Any more questions? In the back, sir. So the question is, are those 600 some views mostly extracts, mostly live? First off, they're not views. The view count would be much higher. Those are workbooks. And I know that our authors tend to pack a lot of tabs into their workbooks. And I don't have a good sense of the split. I know that we're probably up to around 80 extracts at the moment, would be my best guess last time I looked. I would have to guess it's probably around 30 to 40% extract. Yes, sir.
You've done all this with a core server?
Yes.
Have you upgraded to 604?
So the question is, have we done all of this with an 8-core server? Have we upgraded? No. Everything you see today, we are still running on one 8-core license. And how many sites and projects do we have across our server? We made a decision to go with just one site because we did not need to specify security out and limit people just to particular locations. We ended up delivering a project scenario where one area would get 4 different projects. So that has actually ballooned the number of projects we have out into probably at this point around 200. The reason for that is the 4 different projects are where people publish, the core project. We gave them a staging area, which is where we expect them to do their QA. Since we only are using one server and we don't have any promotion from a dev server to a production server, they can put things into a staging project in order to have just their power users have access and test there. We gave them an ad hoc folder so that their web authors can have their location to save their ad hoc reports. And then we gave them a data sources folder, and we put the security on that so that it's only meant for storing data sources for reuse. So we had a little bit of an explosion there, but around 200. Yes, sir. The question is, have we updated our Tableau Server versions? Yes. Unlike other projects and other platforms that we support, it's not difficult for us to do a Tableau upgrade. We average approximately 1 month to install it in Sandbox, test it, and roll it into prod. Our last upgrade was July when we went up to 10.3.1. We tried to schedule them quarterly because 10.4 was released just a couple days prior to October. We decided to skip the October update. But based on this morning's presentation, we're looking forward in January to installing 10.5. Yes, sir?
How are you working on the data governance side? Specifically, let's say you have a, are you using public data source? Let's say you have supply chain data source. How do you avoid the situation when you have 10 different versions of the same data source being created? And how do you work on making those available across the whole enterprise? Something that Tableau calls like certified data source.
So the question is, how are we working on data governance, and how are we making sure that we are not duplicating multiple copies of a given data source created by different people at different times, sharing access? That's one of our challenges today. We don't have much in the way of control over that at the moment. It's something that we're actively striving forward on and looking for ways to bring some kind of governance to. Yes, sir. Sure. So how are we using our security? How are we doing our AD groups? And how are we using them within server? As I mentioned that we had 4 projects typically set up for each area. We also have 4 Active Directory groups that we set up for each area. We have one set up for interactors. We have a second one set up for web authors. A third one is set up for publishers, and the fourth is set up for stage interactors. So as we set up the security on that, the stage interactor group would just have access to the staging folder that I mentioned. Those are the people that you want to do your QA work for you. So typically the stage folder only has, publishers of course have access to all 4 folders. Your stage interactor only has interactor access to that staging folder. Web authors have full rights on the ad hoc folder, and your interactors just have interactor access to the ad hoc folder, the core folder. Everybody only gets connector access to the data source folder, except for publishers who have the ability to publish. Yes, sir. The question is, what size is up our team? My team is only responsible for for the software administration, not for the hardware level itself. We have 3 people, and we are responsible for 3 major BI platforms, of which this is only one. Yes, ma'am. So the question is, have we played around with full versus incremental extracts? Do we have any preference? I don't have a preference at the moment. Most people are using full extract refreshes on their extracts. I did try to play around with incremental. I had problems with the primary key I mentioned when I was trying to extract out of the workgroup database. I don't believe many people are using extract in our situation at the moment. Yes, ma'am. Do we have different project admins? So we really don't have site admins, we just have server admins, of which I would be one. And then project admins don't really exist. That would be people who would be part of the publisher Active Directory group, because they would then have full control over their particular projects. So the question is, how did I hone in on the list of who I'd want to remove from the server? And the answer is, if they're in an Active Directory group, they're golden. Because we import each of those Active Directory groups into our server, that means they'll belong to more groups than just the all users group. And so anyone who belongs to 2 or more groups, they're authenticated on the server. If you only belong to one group, it's the all-user group. That means that whoever owned that particular project has removed you from security. And then it's synchronized. And so we know that you've been removed at that point, and it would be safe to then delete you from the server. We would have to work with those publishers for each individual area to say, hey, you've got 10,000 people in your Active Directory group. Is that really what you need? Oh, no, sorry. And then please clean that up. Yes, sir. Do we have any metrics over how many of our users are active users? It's one of the things I need to create. I don't have that yet. I know I have the information I need to generate that report. I've just not, it's on the list. So the question is, out of the 3,300, I know that they've all logged in at least once. Guarantee you they haven't. I know that when I ran the report, I saw nulls on last login time. And so I know that those are people who have been authenticated on the server, which means they've been added to an Active Directory group, but they are not necessarily using it yet. That is one of our next steps, is to work with people on user adoption. And why are we giving 2,000 people access that they couldn't care less about, because they're clearly not using it? How much time do we have left? Anyone else? Sure.
What does your decision look like for that roadmap going from user-based licensing to
So what did the erosion look like as we moved from user-based licensing to core-based? We never had Tableau Server with user-based licensing. We only had pockets of people using Tableau Desktop and Reader, just small pockets throughout the organization, but Server was not a part of our organization until June 2016. That's when it went live, and it went live as a core-based license. So the comment from the floor is that Tableau is moving away from core-based licensing, and you need to have an exception to use it. Thank you, everyone. Have a wonderful conference.